at this stage already we had in the Ignite session gave you an overview of what this session is all about, and it's basically to provide you information on how weather services at the national and regional and global scale can support risk analysis, and what are the plans for the future also, how to make this information even more readily available to you. And without much more, I would like to, from our side, then introduce the first speaker. Actually, we would like to ask Jean-Baptiste to introduce the speakers. The first one will be then Mariam Golnaraghi. Jean-Baptiste, you'd like to do that?
Yes, so we have online from Geneva, Mariam Golnaraghi, who is the chief of the Disaster Risk Reduction Program of the World Meteorological Organization. And so Mariam is going to present how the WMO is supporting these initiatives related to risk assessment. And I think there is quite news from yesterday's Executive Council of WMO, which decided to support further this initiative of standardization of hazard databases for risk assessment. So I leave the floor to Mariam Golnaraghi. Just let me load your presentation.
Thank you.
I'll let you know. Can you see the screen, Mariam?
Yes, I can.
Okay, so just let me know when you want me to go further.
Good morning, everybody. First of all, I want to thank World Bank and also the Meteorological Service of South Africa for working very closely with us. Meeting. And it's absolutely a pleasure. Part of I'm happy that I can participate by Skype. I could not attend in person because of the Executive Council of WMO, but it's a really wonderful opportunity to be able to discuss with you some of the firm outcomes and commitments of WMO in really advancing the standardization of hazard information and hazard analysis. And this came out of the decisions from the closing session yesterday. So Jean-Baptiste, I know there is not much time, so let's start going through the presentation quickly. As you see for the agenda, I will take very few minutes to talk about WMO so you can understand the structure and, very importantly, the extensive expert network of WMO and its role in working towards standardization of meteorological, hydrological, and climate-related data analysis tools. I will talk about the WMO Disaster Risk Reduction Program, which is the overarching cross-cutting program of WMO, which has really initiated with the WMO network activities that really brings the capacity of WMO networks towards development of products and services to support disaster risk reduction. And then I will delve into more detail into what we're doing to support hazard analysis as critical input to risk modeling and risk analysis. Next slide, please. This slide is meant to essentially summarize the extensive network of WMO. Essentially, WMO coordinates 10 international programs that deal with matters related to the basic systems, that's being essentially space and in situ observing networks, forecasting and modeling capacities, and telecommunication systems that connects all the members of WMO, the 189 members of WMO through their national meteorological services, to ensure that significant amount of data and models and products that are being done by countries and our regional centers are exchanged among all the countries. We essentially deal with monitoring, detecting, forecasting of weather, water, and climate-related matters, and from a point of view of sectors, we have very strong program in agricultural meteorology, very strong program in transport sector, particularly dealing with marine and aeronautical sectors, And the disaster risk reduction, which is now constituted one of the 5 highest priorities of the organization, was initiated as a program in 2003 to really help guide the work of WMO and its members to support these areas. Now, from point of view of our global and regional mechanisms, WMO through its member states hosts 3 World Meteorological Centers, which are data depository for all the data that is being collected by our 189 member countries. We divide the world into 6 regions, which we refer to them as regional associations. These regional associations essentially are forums where directors of meteorological services and directors of hydrological services meet every 4 years to discuss the matters to do with expanding, improving, and strengthening meteorological, hydrological, and climate networks in the regions. We also have something around 50 regional specialized centers, which range from meteorological centers that are thematic or cover the regions all the way to climate centers, and this network is expanding. And then 30 regional training centers that are used for training of meteorologists, hydrologists, and climate operational folks around the world. Now, so the message I want to raise there is massive amount of operational capacity and expertise through this coordinated network of WMO that can be tapped into to support disaster risk reduction and its applications. If you go to the next slide, please. So essentially, at the core of the mandate of WMO is to ensure that members of WMO are monitoring the weather, water, and climatic conditions per certain standards for equipment and observing networks. We have the mandate to set standards for meteorological, hydrological, and climate-related hazard databases, metadata, and very importantly, WMO, through its network of experts, develops and reviews various forecasting tools for weather, water, and climate, and also based on review and performance of these tools, we develop guidance for the countries as to how to operate these tools and what are the different applications that they can be applied to. Very important part of WMO's work is quality assurance and delivery of products and services per certain standards. By that I mean WMO provides guidance to its member countries as to how to provide certain services based on quality management systems. And then finally, something that's highly relevant to the subject that we are talking are the international data sharing policies. For anybody that's interested in doing hazard analysis and risk modeling, I urge that you review Resolution 40 from 12th WMO General Meteorological Congress and Resolution 25 from the 13th WMO Congress, whereby WMO brought all of its members to negotiate exchange of data, and you know, this is a very sensitive issue for a number of reasons which we will get into. So now if you go to the next slide.
May I suggest maybe, Mariam, that we go to the risk identification part, and maybe we come back to that with the session, with the question and answer afterwards? Or
well, before we do that, let me just look at these slides. I think, yeah, sure. In fact, in my comments, I have covered everything, but I would like to go to the slide on the global framework for climate services.
Yeah, sure.
Okay. So, building on this network that I've talked about,
this now one? This one?
We're working towards climate operational information. That's the one. So, you know, significant advancements has taken place with respect to monitoring and forecasting climatic conditions. And one of the efforts that's underway between WMO and its partners is to ensure that all the technology that's being developed among our global centers can be shared with regional climate centers, and the data and information from the countries can feed into our regional climate centers for development of high quality climate services, which then feed back into the country's climate services to develop customized climate products to support our decision making, particularly when it comes to medium to and long-term planning. And this is a very big initiative that will really materialize over the next 10 or 15 years as a continuous work of WMO with its partners, building on the network that's there. So, I would say, Jean-Baptiste, you can maybe now go to the slide that talks about priority hazards. Mm-hmm. Just go, and I will.
Yeah, we are, yeah.
In 2006, we conducted a survey in which 155 countries participated. It's a very detailed technical survey to assess capacities of meteorological services as to whether they have the capacity to support hazard analysis, early warnings, disaster risk financing, all the needs for meteorological, hydrological, and climate information. Now, in this slide, you have the list of hazards which essentially across all our members that participated in the survey was highlighted as hazards where the Met services needed guidance for standards for how to maintain data, metadata, and forecasting and analysis tools to support risk analysis. Droughts, floods, forest and wildfires, anyway, they're listed here. If you go to the next slide, please. I also state that particularly in developing and least developed countries, there is significant challenge for building the capacities of the Met Service to be able to provide this kind of information to the partners who are interested in doing risk analysis. And I want to highlight particularly the fact that 67% of the Met Services require some kind of a modernization of their observing networks and their data management systems to be able to monitor, detect, and maintain the historical databases and metadata for the hazards. Also, 80% of the countries, again, these primarily fall developing and least developed, need technical support for being able to do this work operationally. If you go to the next slide, so essentially this slide, I won't go into it, maybe in the discussion we can address it. This slide summarizes essentially what we have ahead of us in terms of building these capacities of the Met Services so that they can indeed be the provider of crucial hazard data and analysis that's needed for risk modeling. Now, next slide. A key challenge to that is also data policy and exchange issues. Now, the Resolution 40 and 25 of WMO primarily deals with exchange of data among WMO member nations and our regional centers so that our regional centers, and I think today we will have representative from La Réunion, which is one of the WMO regional centers for tropical cyclones serving eastern coast of Africa, is that they provide significant amount of support to the countries. Now, to do that, they need to obtain data from the countries, do the analysis, send the analysis back to the Met Service, who can then provide warnings. Now, Resolution 2540 tackles what are the absolute fundamental information that needs to be exchanged among the countries to be able to do that for saving of lives. But in order to do risk analysis, we need to go beyond that agreement, and there are a number of challenges pertaining to national security, the fact that data is commercial, and the reason for the fact that data is commercial, I really would like to stress this, is that the development and sustainability of the observing networks at the national level is not fully funded by the government. So many Met Services sell the data to be able to subsidize what they are missing. However, what we are finding that in many countries, that funding still gets absorbed by the government and it doesn't go into the Met Service observing network. So this is an issue we need to discuss collectively. Sometimes data is not available and needs to be rescued, and sometimes when you go to the country because of institutional turf issues, it's very difficult to tackle that. Now, to address this issue, WMO will facilitate a number of high-level discussions around the world as part of the projects that we are undertaking with World Bank and other agencies to open up these discussions for next level. Okay, Jean-Baptiste, if you can please go several steps forward, I will tell you, please move. You can hold it in here. Okay, so now, no, go back please, one slide back.
Yeah, these are the 4 EAGs.
Exactly. Now, to address the first need that was expressed by our members, the need for guidelines and standards for development of products and services to support a number of functions, so far we have established a number of user-driven expert advisory groups to be able to guide our work pertaining to what are the needs and requirements for meteorological, hydrological, and climate services, on base of which then our technical arms, our technical commissions will develop the relevant standards for our community to implement. Now, just to go through this, the foundation, essentially the core expert advisory group that WMO will establish this year is the expert advisory group on hazard risk analysis. Essentially, this is the advisory group comprised by experts in risk modeling that are going to guide WMO's work pertaining to what are the needs for hazard data, hazard metadata, and hazard analysis and forecasting tools. So I want to stress again, WMO and its various stakeholders, we are responsible to tackle the hazard issue, not the damage loss issue. So outcome of this expert advisory group will be guidance as to what we need to provide from a point of view of guidance and standards to ensure that every country around the world knows how to maintain its hazard data, metadata, per certain standards, and what kind of tools and methodologies to be used for statistical analysis and forward-looking forecasting to support risk modeling. So if you go to the next slide, very quickly, I'm not going to go over that. This slide essentially summarizes the membership of a number of key international agencies that are supporting countries in risk modeling who are going to be part of this task team, along with a number of experts from academia and our technical community to really delve into the needs for information that's needed out of our community. If you go to the next slide, and that slide essentially is nearly my last slide. In this slide, what I have summarized is what this task team, expert advisory group, in working with our technical experts around the world are going to accomplish. First is development of standards for meteorological, hydrological, and climate-related hazards, primarily the 10 primary hazards that our member states have identified as their priority. That's where we will start. And that is going to span monitoring and detection, maintenance of databases and metadata, and the various statistical and forward-looking hazard analysis tools, GIS-based. We will work to take these standards through ISO certification and adoption by WMO members. And then if you go to the next slide, through a comprehensive national, regional capacity development effort, which has been initiated, and you're seeing the areas where we have started these activities. We will be working with our member states to rescue the data, to help them maintain their data, develop their data management systems per these standards, and also significant capacity building of the experts in the Met services to ensure that they are comfortable with hazard analysis and forecasting tools. For this purpose, we will engage our regional meteorological centers and regional climate centers as a critical mechanism to work with the countries to be able to enhance their capacities. Thank you so much. I'm sure I'm over time, but I hope you found it helpful. Thank you.
Thank you very much. So I have Philippe Caroff from La Réunion trying to call in. I will just need to answer, let him know that we are a little late, and I call you back for some questions. Hello. So we are just a little bit late in the agenda. We just finished with Mariam Golnaraghi. And can you hear me well?
Oui, je vous entends bien.
All right.
Can you hear me well? Okay.
So we will have Andrew Musgrave present the global assessment report and basically how the hazard collection for the global assessment report went from 2007 up to now in relation to tropical cyclone. So can you stay online and just listen at his presentations and then take the floor just after him? I will just put the camera towards the screen so you can follow. Voila. And voila. That's it. Yep. So Andrew, do you want to start now? I will.
Okay, thank you, Jean-Baptiste. Is this working?
Yep.
Yeah. So I've been asked to just make 3 sets of 2-minute presentations explaining how hazard data was used and will be used in Bagar. I'll preface this by saying I'm not a meteorologist or a hydrologist. So please don't ask me very detailed technical questions on how this was done. But in the case of tropical cyclones, up to now we've had a global model which has basically been taken advantage of the information available from NOAA. So this is the cyclone tracks which are globally available from NOAA in the USA. Calculations were made in terms of wind speed, algorithms were used to create a buffer around the cyclone tracks. And this was combined with exposure data, population exposure and GDP exposure for different categories of cyclone wind speed, 1 to 5 on the Saffir-Simpson scale, to arrive at a calculation of risk. That's what's fundamentally been done up to now. Storm surge was calculated in a very, very simple way, taking average wave height for each of the Saffir-Simpson scales and using a digital elevation model to estimate the flooded area from storm surge. That's what's been done in Bagar up to now. A new model is currently under development, which is we're moving now towards a probabilistic model. So a stochastic approach is being taken in which thousands of synthetic cyclone tracks are being developed. And this will enable us to have a more of a stochastic probabilistic calculation of cyclone impacts in different areas. And we're currently comparing 2 ways of improving the storm surge model. One is obviously continuing with the existing approach, but a second approach is being also looked into using bathymetric data. One of the limitations here, and this is perhaps where we touch again on data issues, is that currently global bathymetric data is only available at a very low resolution. Our impression is we need high resolution data to get an accuracy of a model. But we're currently comparing the results we can get from low resolution bathymetric data results from the existing approach, which, as I said, is just flooding a digital elevation model with average wave heights, and comparing this with observed storm surge impacts in areas where we can get this from satellite imagery, and we're going to see which of the two approaches calibrates best. So that, I think, is my 2 minutes up on tropical cyclones.
Perfectly on time.
Bon, ça va être bon.
So Philippe Karoff is the chief forecaster for tropical cyclone in La Réunion Regional Specialized Meteorological Centers. He's basically in charge of forecasting cyclone tracks in all the Indian Ocean part of this basin. And I will just load your presentation. Can you see the screen, Philippe Karoff?
Partly, yes.
Okay, I'm just trying to adjust that. Okay, like that, maybe better. Voila. So, just let me load your presentation. That's it. Okay, we are ready.
Good morning from La Réunion. So I'm Philippe Karoff, operational head of RSMC La Réunion. So I'll make a presentation about tropical cyclone and associated risk modeling. Next slide, please. Next one. So my presentation will be in 3 parts. The first part will talk about general consideration about tropical cyclone monitoring worldwide through a specific organization from WMO with RSNCs. Afterwards, we'll talk about available tropical cyclone hazard information. And the last point will be about using this information for risk modeling. Next slide.
This one?
Yes, as you may know, tropical cyclone is a major natural hazard. Looking at statistics from the United Nations, you can see that all natural hazards considered, not only meteorological ones, but also hazards like earthquakes, tsunami, etc. Tropical cyclones represent about 20 to 30% of all damages, mortality, and number of people being affected worldwide, which does represent several thousand people every year. So it's a very important natural hazard with a lot of consequences. And now looking at the areas impacted potentially, as indicated by the name, cyclones are tropical phenomena developing over waters of warm seawaters of tropics. So they affect most of tropical areas, except a few exceptions like Southeast Pacific or mostly, or Southern Atlantic. But otherwise, all basins are affected. And you can see here a representation of 20 years of tropical cyclone tracks on different basins, and most active one being the North Pacific. Next slide. So we defined what is called tropical cyclone basins. And for our regions, for the Southern Indian Ocean, we have about 20% of the worldwide activity, about which 9% is focused on the Southwest Indian Ocean, our area of consideration. Next slide. So considering the importance of the tropical cyclone phenomenon and all its related consequences, WMO organized a specific organization dedicated to the monitoring of this specific meteorological phenomenon. And this is made through a specific organization with dedicated centers of expertise that have been designed and on the different basins. For example, the Regional Specialized Meteorological Center of Miami, the National Hurricane Center in Miami, is the most famous one. It is well known, and it has a responsibility for monitoring tropical cyclones in the Northern Atlantic and in the Eastern Pacific. Next slide. Of course, as I mentioned earlier, the Southern Indian Ocean is also affected by tropical cyclones, and the Southwest Indian Ocean especially. Considering just the first decade of early 2000, from 2000 to 2010, we have almost 2,000 deaths recorded in the area, mostly in Madagascar, which is the most affected country in the region. So it is really an important phenomenon and a major natural hazard for our region. Next slide. La Réunion, Meteo France La Réunion has been designated as a regional specialized meteorological center for the Southwest Indian Ocean in 1993. So we have three main missions. Main one is the operational monitoring of tropical cyclones. So we are responsible for providing first-level information, which analysis, forecasts, guidance, and warnings for all tropical disturbances forming within our area of responsibility. And we have also two missions, one of research and one of formation. Next slide. Our area of responsibility covers some 20 million kilometers square in the Southwest Indian Ocean, from the equator to 40 degrees south and from 19 degrees east to Africa. So we work basically for the benefit of 15 member countries of the Southwest Indian Oceans with the National Meteorological and Hydrological Services, all of them belonging to a specialized group called the Tropical Cyclone Committee of the Southwest Indian Ocean. And the main goal is, of course, to reduce the loss of lives and to mitigate the socio-economic impacts and damages caused by tropical cyclone in our region. Next slide. So now I'll talk a little bit about tropical cyclone hazard information and their availability. Of course, next slide. So, of course, our major mission is to ensure the operational monitoring, forecasting of tropical cyclone. But of course, we also keep the memory of the climatology of tropical system developing in our region. And as a prominent byproduct of our operational activity, we maintain historical databases of tropical storms and cyclones. In particular, the ones called best track databases that include 6-hourly positions of the storm centers and all relevant related parameters of intensity, size, and structure. So the databases maintained by RSMCs constitute the main basis, of course, for all tropical cyclone-related studies, applications, etc. Among these possibility of application, of course, we have risk mapping linked to tropical cyclone activity and impacts. Of course, the basic product is track mapping, like the one for the last cyclone season in 2001-2012 on the bottom left side of the image. Next. Of course, you can make, with the database, you can make all statistics and treatment you want. One basic one is to assess tropical cyclone hazard at local scale. So you have an example here with La Réunion Island. We have here all tropical cyclones having passed less than 100 kilometers from our island at hurricane force stage for the period 1961-2010. So it's about 10 systems, 10 cyclones, major cyclones having passed very close from our island. Next slide. This can be done, of course, for all countries in the region. Another example here with Madagascar, tropical cyclone landfalls for the period 1963 to 2009. And we have 3 maps above, stratified by latitudes, showing all the impacts and landfalls on the Madagascar, which for this period represent 41 landfalls, almost one every year in average, mostly placed between 15 degrees south and 20 degrees south. Most of them, of course, hit on the east coast, but with the Mozambique Channel on the west side, you also have about 50% of landfalls taking place along with the west side of the island. Next. Of course, this is one landfall in average, but of course some years are much more destructive. We have the case of 1993-1994, which was called Annus Horribilis for Madagascar, with 5 landfalls on this cyclone season, including 4 at intense tropical cyclone stage, with a lot of damage and fatalities recorded on the island, unfortunately. And on the right side of the slide, you can see also a composite image of 2006-2007 tropical cyclone season, with different with 4 cyclones, major cyclone, intense cyclone, roaming around the coast of Madagascar, some of them, like in Lala, making landfall on the island. Next. You can also use best track data for assessing tropical cyclone hazard at regional or global scale. This is an example for Southern Hemisphere, so Southern Indian Ocean and Southern Pacific, with the annual frequency of tropical cyclones taking place for these 2 basins during a 30 years period of reference. So you can see, for instance, the Northwest Australia region, which is really prone to tropical cyclones. But of course, you can make all the treatments and more sophisticated mapping. For instance, considering linking tropical cyclone activity to ENSO, so an El Niño Southern Oscillation. Next slide. So you have an example of mapping where the average frequency for El Niño years, and you can see, for instance, for the Southern Indian Ocean, that there is a displacement of a tropical cyclone activity to the west or central part of the basin, more to the west, compared to La Nina years. On the next slide. Yep. Well, during La Nina years, conversely, activity is less on the western part of the Southern Indian Ocean and is displaced to the east region. So basically from 80 degrees east to 100 degrees east. Next. To make this kind of statistic mapping, you need to have a database of good quality. The reason why we have undertaken a reanalysis project of our historical database, our best track database, because it's a high priority for tropical cyclones. It is considered a high priority, and that was a major recommendation from international workshops on tropical cyclones, number 5 and number 6, that took place in the past years. And the reason why we have undertaken a pluriannual reanalysis project on past satellite data, focusing mostly on the period 1978-1998, in order to better the content and quality of our historical best track database and to put it at the state-of-the-art level. The reason main reason of that is that in the past, mostly prior to 1991, the satellite picture received at La Réunion were really basic satellite pictures. Mostly it was hard copy, like photographs, it was not digital imagery. So it was really poor quality imagery. And now we have, of course, digital imagery. But we the past of satellite imagery less or poorly exploited, and of course also the techniques used to analyze the pictures, like the drag technique, was which started in 1984, was not used prior to this date, or used. So it's the main reason why we will analyze all the satellite imagery for the 80s most. Next slide.
Next from here, or?
Yes.
This one is good, or the next one?
No, not yet. Next one.
Okay, sorry.
And now we have archives, have access to archives of digital imagery from the 1970s and 1980s, thanks to a database of satellite imagery dedicated to tropical cyclones, maintained by National Climatic Data Center of NOAA, the US, and its base is called URSAT. And thanks to this base, we'll reanalyze all the satellite imagery for the past decades.
Do you think we can go to the end in 2-3 minutes? Should we skip some slides or
No,
we
come
go?
on, let's
Yeah,
go on.
okay.
Next. Okay, now last part, we will talk about a few examples of using the topical cyclone hazard information for risk modeling. Next. So a few words about a project which is ongoing. It's a private engineering firm called GBA, Risk Management Limited, from the UK, which has been solicited by the CCR, a reinsurance central bureau of France, a reinsurance company, for developing a single and multi-period model for La Réunion Island, dealing with the following meteorological related hazards: sea surge flood, windstorm, surface water flooding due to heavy rainfall runoff, either for cyclone or non-cyclone events. So this model will include both probabilistic and deterministic components. It will be accompanied by deterministic flood hazard maps for sea surge and surface water flood. Hazard maps providing the extent and depth of flooding for given return periods will be developed for sea surge and surface water flooding. And inclusion of a built environmental model and of vulnerability functions relating hazard intensity to the expected mean damage ratio, and hence enable the calculation of ground-up loss for property in the probabilistic model, will enable the quantification of return period losses and the output of a loss exceedance curve and event by event losses. Next. So this project of risk modeling will of course require the access to different databases, including cyclone data information. So Meteo France has started for providing access to its historical database, storm, providing access to the climatological records of wind and rainfall observation on an island, and also serving as a check the specifications of the project. So this was the second one is an work on storm surge undertaken by France La Réunion. So as an ongoing project on tropical cyclone-induced storm surge, using our storm surge model, first step will aim to generate an atlas of potential storm surge depending on TC intensity, tropical cyclone structure, size, radius of maximum winds, etc. Of course, for a number of coastal sites of the region, from Mozambique and Madagascar mostly, selected for their socio-economic importance and our vulnerability. This database linked this atlas serves as first level guidance for the tropical cyclone forecaster during operational assessment of storm surge during real TC events. Next. This kind of work, atlas mapping of storm surge, was already done for La Réunion in the early 90s. And this is a kind of result we can obtain with this atlas of storm surge. So you have here a chart showing the maximum height of sea level rise on the coast of La Réunion due to storm surge, as simulated with the Meteo France storm surge model. So you have the figures here that indicate, in fact, the maximum height of sea level rise for the worst case scenarios for each point of the coast. And as you can see, the maximum height is less than 1.5 meters. This is due to the volcanic geology of the island and with the steep bathymetry around the island, which means that the island is little affected by storm surge, which is not the case, for instance, for big countries like Mozambique. So this is an important project for us to work with WMO for storm surge warning the region. Thank you for your attention.
Thank you very much. So we may take only one question before we go to the floods. Is there somebody willing to explore more? And, let me just can't see what you have here. Okay. Does anybody want to have one short question? Yeah, we have Colonel Mami from Madagascar. Let the microphone on the left. Yeah.
Thank you very much for your good presentation. My question about available data that you collected about Madagascar, is it how to have it? Is it free or we need to some protocol to have this probabilistic that you did and the study that you make? Thank you.
Sorry, I did not understand very well. It was partly cut, the question. Could you please ask again? Maybe in French?
No. Thank you very much for your good presentation. Normally, you have many data and probabilistic did, and of course, modeling about the tropical cyclone. My question is how to have it. Is it disponible in the website, or you need to ask about the protocol, or which kind of system you can have this result of your research?
Well, the database is available on our website, but more easily by direct request to us. And the works done by us are, some of them are available on internet, but not all. Huh? So if you want specific information, the best is to ask us by email, and we will answer.
Thank you very much. We have to move on to the next presentation on floods, and so I will have to cut the connection. And thank you again, and I will just follow up by email with you, Philippe Karoff. Thank you. So I will bring now on the screen basically the hazard map that is being used for flood in the global assessment report. And if Andrew wants also to give us a bit of background on how this was developed, and then we'll again have a more concrete example of how flood hazard data is being developed by Osborne Sheila.
Okay, thank you, Jean-Baptiste. So this is my next 2-minute intervention. This model, the global flood model, which is available through VGAR. I should say also for cyclones as well, all this information is publicly available. You can consult it and download it from the internet. Basically, it's a model of riverine flooding. As you know, for different kinds of flooding, we have riverine flooding, surface water flooding, flash flooding, coastal flooding. So this model is only of riverine flooding. It's a model that's built on river flow data, so it's not a rainfall-based model. It's a hydroshed-based model. And it's a model which currently only calculates one returning period of floods. It calculates 100-year floods in major river basins. We've done testing of this model against observed floods, observed major floods. Recently, we've done the Thailand floods, the Pakistan floods, etc. The model gives, I would say, reasonably credible results. Under development this year, a product which will be ready by December. The model is moving into multiple returning periods. So it will be developed for 20, 50, 100, 200-year floods, at least 5 returning periods. And the plan by 2015 is to move, again, as we are doing with tropical cyclones, into a fully stochastic model in which the hydroshed river flow data is actually combined with precipitation data to be able to actually have a probabilistic flood model. I will also mention a serious limitation of this, and I think almost any other global flood model we've seen, which is obviously the difficulty at the global scale of incorporating information on flood management, flood mitigation infrastructure. There's not a single river in the world now which flows naturally through its course. All rivers are modified through dams, dikes, levees, sluice gates, and a series of other elements of infrastructure. At the global scale, it's impossible to incorporate this very dynamic infrastructure into the model, and I think this is one of the major limitations of flood modeling we would put on the table. So I think with that, I've, again, exhausted my 2 minutes and will stop. Thank you.
This was a very good overview. So now I'm calling Osborne Chela to present the experience in the Zambezi River Basin in Malawi. And I will just load your presentation.
Thank you. Good morning. Okay, I'm going to present something which is, it's a project which is ongoing. It has not been completed. But the basic principle behind it is, what do we need? What information do we need? Oh, sorry. Why is it advancing on its own? Am I slow or?
So let's fix that. So this is just the ignite. Voila. Okay. Sorry.
Okay. So basically, the information we won't need about hazard. We want something that can answer all the questions that we have. When are we going to get flooded? Am I safe to build here? Is the bridge here okay? Things like that. So maybe I've shown you the picture here, which shows the part of the Zambezi, but this is a tributary of Zambezi in Malawi. And to just give you a scale, you know, from, my mouse has disappeared. Joe? Well, but I can just tell you that from the top, along the river, from the top to bottom, it's about 150 kilometers.
You can make it appear. Yeah. You have this also if you want to point.
Yeah. From here to here is about 150 kilometers. And you see the boundary between Mozambique and Malawi here. This is Mozambique, and this is Malawi. I'm basically going to go through hydrological modeling and flood hazard database or information. Then what are the roles of National Meteorological Services and the contributions. Then the National Hydrological Services, then the roles and the contributions of national disaster management authorities, then regional comparison contributions. This is regional organizations, but mainly targeting the cooperating partners. Then what can we do with the hazard information? and how can we improve it. Basically, to do the flood hazard analysis, what is required or what is being done is to do rainfall occurrence and the return period analysis to come up with the statistics for areas for maybe 2-year return period, 5-year return period, 100-year return period. The same thing for hydrological parameters. Then from there you do the modeling, runoff rainfall modeling to see how rainfall in vase of various return periods of magnitude, what runoff can they generate or what floods can they cause. Then the hydraulic models that essentially translate track down the running of the runoff along the rivers and surface models. And then the hydrodynamic modeling that tracks the flows of the river in terms of area of coverage, depth, and the distances. Then essentially these models, of course, they require the weather, climate, and hydrological data that is measured directly or indirectly through remote sensing such as satellites and so forth. Then you have the physical data that you need, like topography, soils, geology, land use cover. Again, this has been a combination of using satellite data as well as ground data. Of course, you can't forget the manpower. There are several ways you can do the dynamic modeling, but the system that was used is being used in Malawi is what is called InfoWorks networks, where you have a grid of a 3-point grid or triangular grid system that connects the whole area. This is just an example of this. It can be three-dimensional, but in this case, it was only limited to 1 and 2 dimensional. And the result is this. If you see the picture on your left, sorry. On the left side, it's a 5-year flood superimposed on a topographic map, which is 101 to 50,000 map. If you remember my original satellite picture, this is just represents the upper half of that that picture, but the information transposed on a 1 to 50,000 map. You can also see that the left picture doesn't have all the area, the flood plain area inundated. You have some areas where you can seek refuge when you have floods. The right picture, you notice that most of the area has been covered, and actually there's a famous sugarcane estate here. Almost 1/4 of it would be flooded. Now, about the roles of National Meteorological Services, obviously we need the climate and weather monitoring and data collection done by them. But what is of emphasis is rainfall data analysis and publication. You find most of the data which has been archived at the National Hydrological Services, they lack analyzed data or published data. So when a research or a consultant wants to get the data, he has to actually extract it and make it in a usable form, which almost takes time. But probably the best is that every year we should be analyzing what we have collected, compare them, and then publish them ready for use. The same thing with the, if you want to get maybe the annual rainfall, a maximum annual rainfall, maybe for 2, 3, 4, 5 hours, it's also very difficult to get. You have to go through the data and compare it yourself. But if it was an annual habit, each time you summarize the data and compare it, the better. The same thing with the National Hydrological Services. The 3 areas that I've covered also needs attention. The National Disaster Management Authorities, of course, I think their responsibilities or roles or contribution would be verification of these flood losses and damages in areas that get flooded, which can also be feedback to the models. A good example is that as you have been hearing, the topography in these models is based on this digital elevation modeling, and normally it's 90 by 90 meters. That's what was used here. And the resolution, vertical resolution, is only 1 plus or minus 1 meter. So it's quite coarse. You may even predict that this area has a flood when actually there are no floods. So information, the actual information from the disaster authorities would improve to check, to improve this, for example. The same thing that when these results are out, it's the Met authorities that can sensitize the communities to say that this area is predicted that if you have such type of a flood, you get flooded. At the same time, it's also good to give a feedback to the people who are working on this. I also think that you see this type of modeling, as we have seen here, is a specialized type of modeling. So obviously the regional cooperating partners, World Bank, WMO, UNDP, EU, and the rest, they are encouraged to provide technical assistance. I'm not lobbying on behalf of the countries, but this is a fact. The countries, particularly here in Southern Africa, cannot afford this type of technical assistance. It's imported from Europe. We haven't really been able to develop our own here and there. But at the same time, I think they could even go further by using such type of results to influence and promote policy reforms among the governments that they cooperate with, so that they should be advocating prevention more than relief. I think this is what has been echoed. I'm just emphasizing there. It's better to prevent a crisis rather than rushing to waiting for it to happen, and you spend more money than when you prevent it. And I think the cooperating partners can also encourage countries to the countries should be aiming at flood hazard protection schemes, such as dikes and so forth. I know in Zambezi there used to be dikes, but the dikes, they all got breached and they have never been repaired. So you find that this, when the floods come, is quite destructive. I have also tried to see what sort of products can come from this. Obviously, as you have seen, you have these flood hazards, but at the same time, you also have, you can, from such type of analysis, you can also have come up with design floods, so that your bridges or dams or even areas where you think you can build are guided by such type of studies, so that you prevent breaching of the bridges or breaching of the roads if you build high enough with the design floods of higher return period, like 100 year and so forth. Then it's also a good tool that you can use in actual issuing of flood warnings, because with this type of tool, whenever you have forecasted a flood, you can relate it to the actual areas that will be inundated with the floods. I think also to manage this well, you need feedback and collaboration among stakeholders, not only within the country, but across the countries, since Zambezi is shared by 8 countries. The same thing with the product use from such type of work. You need to disseminate it. Not only that, get a feedback on the performance of the. But I think something which is also important here is that this, as I've said, the study is just new, and most of its performance now need to be improved. As I've said, one, the use of, if you can use reader data, it will be much more improved than the way it is now. But at the same time, I think it can also be extended to that part of Roa Zambezi, which is in Mozambique. And I think it can also be extended to even upper areas where you get floods, like in Shobe or Kafue floods, or in the Barose flood plains. But I also think that this can also influence national policies in terms of settlements and so forth. The areas that get flooded, they almost get flooded every year. And every year, the governments have to take relief items there. Why not say, we have to live with these floods. This area is not good for resettlement. You move to another areas which are safe, and these are the tools which can show us where this is safe. I think it can also influence the governments on the budgetary allocations. I know the hydrological and meteorological services are among the least departments to get priorities for budget allocation. But if we show that we can save government money, I'm really sure they will listen and prioritize our areas for national budget. But not only national budget, even the support we get from our cooperating partners. Thank you very much.
Thank you very much, Osborne. I have the feeling that you are not working only with the National Met and Hydro Services, but also with a whole range of stakeholders. I may invite those of you that want to have more details about how to work with the Met and Hydro Service, maybe to talk directly to Osborne, because we have Roger Pulwarty, who is waiting for a call from Boulder in Colorado. It's 4 a.m. for him, and he's going to speak about drought, so I'm just going to connect him. And in the meantime, if Andrew, you want to explain how you are in the global assessment report with drought, and Roger Pulwarty, I think, is working closely with you on that, so it will be a very direct follow-up.
So here is my third 2-minute slot. Roger, are you there? No, not yet. Yeah.
Not yet.
Okay, so I think we actually yesterday in the Global Assessment Report session, we did 2 quite detailed presentations on work which is ongoing currently on drought for the Global Assessment Report. But I would just say that, historically, this has been the single hazard type where I think we're further behind in modeling in the global level compared to anything else. In the previous GARs, we've described drought risk really as an invisible or a hidden risk globally, simply because we don't have good models available. In the previous exercises we've done in the GAR, I think we've just managed to have an approximation globally of meteorological drought hazard. Recently, WMO has established the SPI, the Standardized Precipitation Index, as a kind of a global norm for measuring the meteorological hazard. But actually moving from hazard to risk is a far more complicated procedure. We're currently working in 2 different directions. One is on agricultural drought hazard and exposure, trying to get a sort of a broad brush estimation, at least for 2 regions of the world. One is Africa and the other is the Mediterranean basin. That is the work that was presented to you yesterday by Dr. Wadid Arian of AGSAD. And we're also then, in countries where data exists, trying to actually then drill down using a different methodology, which was presented yesterday by colleagues from FuseNet, in actually developing probabilistic loss exceedance curves for the major cereal crops like millet and maize. But I would say that on drought, I think the principal limitation we have is on data availability. Very few countries maintain detailed loss data, on decline in yields or on crop losses during droughts. So I still think this makes the development of a global drought risk model an extremely challenging venture. We're having some further discussion on that actually this afternoon with our partners, but I think we are talking more about a horizon of here to 2015 at least, before we can get some credible results on the risk side. So summary, I think we're good on the hazard side. The existing meteorological data allows us to do that. We're gradually getting there on the exposure side, but risk we still only, I think, have conquered, let's say, 3 or 4 countries at this point in time. So that means we have another 190 to go before we can get to a global risk model. Thank you.
So, Roger, can you hear us? We can't hear you. I'm just trying to set up the sound here. Hi, Roger. So, let me see. Okay, we may try to use the phone connection since. Okay. You think we should use the phone? Hi, Roger. Are you hearing us? I think it just came back. It just was coming back when you closed. Yes, hello. We can see you and we can hear you.
Hi. How's our connection? No?
Yeah, we had a little connection problem, so you just missed
Okay.
the introduction from Andrew that presented basically how the global assessment report on a global level is addressing drought. And now your presentation is loaded and you can, you can have the floor.
Thank
Yeah, we can't hear you very well.
Yeah, I know there seems to be a little bit of an issue.
Okay, now it's perfect.
Okay, yeah, if you can't hear me, I will make more sense. Okay, so let's start. As I said last night, for some of those who were there, my name's Roger Polwarty. I run something called the Climate and Societal Interactions Group at NOAA, the National Oceanic and Atmospheric Administration, and within that is the National Integrated Drought Information System. And I'm going to speak a little bit about climate services and drought and the role of national met and hydro services. I wanted to start by having a quote from a very famous paper called Information in Organizations as Signal and Symbol from Martha Feldman and James March. It says, rules for gathering, storing, communicating, and using information are essential elements of organizational operating procedure. At the same time, a friend in common to Andrew and myself, Alan Lavelle, says, neither society nor the environment are static. Consequently, neither is the risk. So as we begin, next slide, as we begin to talk, as I mentioned yesterday, for some of those who were there, we have started to do an assessment of drought early warning systems around the world, and we've looked at about 21 of these. I'm going to speak to some of the lessons for climate services and then point more directly to the types of issues that services in the context of a changing environment might require, especially when national met and hydro services are concerned. So those are the locations of some of these, and in the corner is the start of the report that we're doing. Next slide. So from this standpoint, many of the people in the room know.
We lost you.
Yes.
Yeah, it's coming back.
Okay, good. Yeah, many people know that there are challenges in assessing drought. They're cumulative over time. It's not the same as dealing with hurricanes or tornadoes or anything like that. We have many different kinds of indicators, from the Farmer Drought Severity Index to, we heard a whole lot about the Water Resources Satisfaction Index, the Surface Water Supply, and newer integrated indices, such as the Vegetation Drought Response Index, that tries to combine traditional drought indices, such as the Farmer Drought, with vegetation changes. And these are all being used, as people in the room know, through our partners in places like FuseNet and so on, for food and water security outlooks. So when we assess these 21 cases and we look through the indicator and the challenge, and we look at how they're being used, we begin to ask a set of other questions. Next slide. And the questions have to do with, well, what are the constraints on implementation given this better information? One of the things that we're seeing is the lack of specificity about non-El Nino related years. And as I mentioned yesterday, there's an issue with even understanding how El Nino years.
Yep, we just lost you since 2 seconds. We may try with the phone, maybe. Yeah, we'll call you back. Are you here?
JB, are you there?
Yeah.
Okay, good. So the next slide, if
Yeah.
we build the architecture for an early warning system from all of these cases, as with other things, we've got the research and monitoring component, decision support tools, the services delivery, and probably the most critical piece, which is capacity and coordination. Who is to do it and how are they to work together? Next slide. So given those cases, we can ask, what is the role of a national met and hydro services in this context? The first role is to define the core set of data, the data characteristics, and the information technologies needed to maintain some minimum level of stewardship for managing drought risk to communities. The second is to converge on definitions and concepts. People use product and services interchangeably, and we have to have some agreement on what these mean in the way that we're using them. We use product to a general term synthesis, evaluation, and information that contributes more broadly to the welfare of communities and the nation. So we have to be clear that we're not supporting decision support tools as a substitute.
The connection is not
To
very
develop
good
a
yet.
collaborative framework between research, impacts assessment, and management. We've asked for this in many cases before, and we have a few cases around the world in which this has been done, in which there's a strong link to research. It's very common to say in the case of drought, we need to use the policy window that opens in drought. But if we do not have this collaborative framework between management, then that window is not open. So how we take climate information, fit it into the hydrographs, the probabilistic risk assessment, placing multiple indicators within a statistically consistent trigger framework is completely dependent on how we develop the risk profiles through this collaborative, and I'm going to come back to that. Next slide. Another critical aspect, given these cases, is prototyping and learning. How do we learn about emergent risks in a changing environment? Having the right people to overcome impediments to the flow of information and to information systems working as systems. A critical aspect of that we have done very little work on is post-audits and evaluation. How well are these things working? Who is getting what information, but how is capacity being increased? Which institutions now have better plans? Which communities have better plans? And how does new information relate to what is already known? How often do we consider data? So those are 4 areas that are needed to strengthen national met and hydrologic services. And one of the things I wanted to show.
We lost you again, Roger. Do you want me to try to call you on your phone? Yeah, let's try that. Okay. We are just calling you. So, +1 for US. So it's Julius? Yeah. Connect you back here, and we have the last try, and otherwise we go to the phone. I just need to disconnect you from there. Shall we go to your presentation, and then we move back to Roger when the connection gets better? So basically, Eugene Pullman is the head of the Disaster Risk Reduction Department in the South Africa Weather Service, and is going basically to explain how South Africa has been using this risk information with different stakeholders, how the South Africa Met Service has been interacting with stakeholders, and is then going to show how all this information developed by the Met and Hydro Service is getting available through the WMO information system and global climate framework services so that it can be used for risk mapping. We'll try to be very fast, as I know we are already late. So.
Well, thanks, John Baptiste. I think this session is probably the only one that has done some remote activities, and which is typical of the weather environment. In any case, we are connected internationally. We are connected with between various Met services and regional centers and global centers. And this is also what I would like to highlight somewhat in this discussion. I think I've got a message up here that I don't need. It is gone. So, weather services are heavily involved in disaster risk reduction activities, and why would that be? In Southern Africa, 95% of natural disasters are weather related, and this is clear from this information from the CRE database. And the most important disasters that we have in Southern Africa, just as an example, is drought, floods, windstorms, and epidemics, typically in the list, as Mariam has also had in the very first presentation. So, no wonder then that National Met Services are, as I mentioned, at the forefront of disaster risk reduction. And typically there are two major activities that we are involved in. One is to do with severe weather early warnings, and the other one is to do with weather observations, and then climate information and data, and the archiving and making available products from that. Now, to start off with observation networks and data, first of all, weather services worldwide measure or observe various data parameters and data types. And we do that on in the atmosphere. Even oceanic measurements are being done, typically the weather parameters and some sea surface temperatures, for example, and things like that. And there are also some terrestrial parameters that's being observed by certain weather services or parts of weather services in the world. Typically, if we look at the data coverage on the surface, this is a map from the European Centre for Medium Range Weather Forecasting, showing that on the 27th of June at 12 UTC, a total amount of 36,000 observations came in just for that one particular hour. And that was available to all the Met services around the world through the global telecommunication system I'll talk about later. So there's a massive amount of data coming in regularly, every hour, every 6 hours, from all the weather service around the world. And it's basically the weather service that do the observations. Although it's being used globally by other centers, it's being measured nationally by the weather service itself. There are problem areas. We can see the areas where, particularly in the tropics, where less observations are available. But then there are also other ways and means that some of that data can be subsetted by, for example, you making use of satellite information and so forth. A very important subset of this data is the Global Atmospheric Watch information that's made available by the so-called GAW stations. And there are a number of them around the world, also run through the WMO system. One of them, for example, at Cape Point over here is being run by the South African Weather Service, and we've got data there spanning 30 to 40 years that's being used in the climate change environment particularly. Typically greenhouse gas data being measured by that one. Now, a weather service like the South African Weather Service would then make observations through its own network of weather stations. We've got a host of different kinds of weather stations that's over there, as well as other data sets like a radar network, information from the radar networks being measured and archived. Lightning detection network, we've now recently added the air quality monitoring system in South Africa also. And typically, we would then archive all this information in our climate database. And that's being done by most weather services around the world also, some to a better extent and some to a lesser extent, depending on the capabilities of that particular weather service. But there's a lot of effort being done through the WMO to try and make sure that this data is being archived in a standardized format then also. As I mentioned, one of the activities of weather service that's important in the risk area has to do with early warnings and early warning services. And we are active as national entities, but particularly also collaborate in regional format in this particular system. If I can just go down to the bottom graph of this, or map of this particular one, it's talking about the seasonal early warnings that we issue, particularly regional climate outlook fora has been established worldwide in those particular areas, providing forecasts for the next couple of months on a seasonal timescale, as we call it, that can be then used in risk analysis and as part of the hazard information for disaster activities and other activities also. But we've also recently added a short-range forecasting regional collaboration mechanism. The first one was designed here in Southern Africa. It's being run by the WMO. It's called the Severe Weather Forecast Demonstration Project, and we've now expanded this to four other regions also around the world. In the Southern African case, every day we issue guidance from the regional center in Pretoria to 16 national centers of what potential severe weather hazards can occur, and they then decide themselves, those national Met services, if they want to issue a warning or not from the guidance that we produce. And this is being deemed from a weather service perspective as a very successful effort, and that's why it's being rolled out to other regions also. So the regional collaboration is very active in this field on early warnings. Typically, the South African situation, we've got a multi-hazard early warning system in the country, and it deals with various monitoring authorities, measuring various kinds of hazards. That's all being then eventually dealt with, or the plan is to deal with them in a standardized way and disseminate the information to the disaster management fraternity, media, communities at risk, and so forth. And the severe weather warning system of the Weather Service is part and parcel of this national multi-hazard early warning system. There are various ways that we collaborate with partners out there in terms of making our data available for risk analysis, and one of them would be to the disaster management structures, which is one of our most important collaborators also. And we have collaboration at all levels between the Weather Service in South Africa and disaster management centers. The Weather Service provides real-time early warnings, information to the disaster management centers, to their joint operation centers and so forth. And we also provide reports and data and weather and climate related products for hazards and risk assessments of various disaster management structures for municipalities and so forth. We've contributed a significant amount of information already in various reports and assessments that's been done. And another aspect that in South Africa that we do is we maintain the so-called CALEM document, which is a log of weather events from newspaper reports since 1900 that's being used quite extensively also by our disaster management structures. This is a typical product from the CALEM that's being done by the National Disaster Management Centre, where they've just basically showed where the different kind of hazards, as we've logged it from the newspapers, has occurred over the last century or so. The graph in the bottom is one where we can then just nail down into a specific district municipality, in this case Cape Town, which are typically the number of weather-related hazards events that's being shown and that typically occur in this area, that's being reported in the newspapers also. A very useful and handy kind of database already being used. We also provide information now on flash flood warning systems that's recently being implemented in South Africa and now being rolled out to, as you can see, to large parts of Southern Africa. This information goes directly to the Disaster Management Centre and as well as to some water sector departments. And we use this not only for providing hourly guidance on potential for flash flooding, but also in the future, as we archive this information, we'll be able to provide some climatic information also on where most likely flash flooding can occur. Agriculture is a very important activity that we work with, or sector that we work with, and there are various products that are used by the agricultural sector: seasonal forecasts, SPI maps, historical rain maps, etc. One can go on with a list of information that we provide to them and that's been used by them in terms of immediate planning, as well as that's available for risk assessments. Seasonal forecast information is obviously nowadays in Southern Africa very important, and there are various ways that this information can be then packaged to make available useful information for the agricultural as well as for disaster management and even the water fraternity also in the case of seasonal forecasts. And then finally, an area that we work on also strongly is with commerce and industry and even the finance and insurance sectors, where we partner with companies that produce then specific products that's made available to try and support risk analysis by these different sectors. For example, on the top right you can see a total lightning risk for 5 years, 2006 to 2011, which is very important and being used by the finance and insurance sectors, for example. Banks are very they like to use the SPI maps, for example, in terms of drought indicators, and all sorts of other kind of drought information that's also for their use. So in conclusion on this short presentation, weather services are at the forefront of weather-related hazards. The standards for observations and data exchange and climate databases are set by the WMO, but the weather information for risk assessments are generated and maintained at the national level, and that's where they are also then available. Various weather and climate-related information and products is available in support for risk assessments, and one should try and get access to this from the different weather services as you need them. Obviously, they have their own methodology of distributing this information, but this can be done, we would urge for more use of this information globally from the weather services. That would be my presentation from a National Met perspective. Then lastly, I need to also give a short presentation on the
Roger is waiting for us from Bulldog. Can we just
Sure.
connect with him 5 minutes? He can give us a very quick, brief overview instead of the long presentation. And then we finish on basically how the WMO framework is making this data available.
Sure.
Yeah. directly one? No, it's one. Yeah. We are very sorry for being so late. Hello, Roger. Now the Skype connection is really not working well. Can I suggest that you try to give us another? Do you want to use the slides as support, or do you prefer just to talk on the slides?
Well, do you have the slides up? Because there's a couple things in there I wouldn't mind just showing.
Yeah, okay. So we can go very briefly with them.
Yeah, let's go quickly. Yeah, if you go to slide number 9, which is where we were.
Yeah, I'm there.
Right. Do you have it?
Yes. Yeah, it's on.
Okay, good. So just to recap, the role of the math and microservices define that core set of data, convergence on definitions and concepts, this collaborative framework between research and management that can use Windows effectively, prototyping and learning, and then where we are on this slide is basically an example of one of the cases that we did with people who were affected in different areas, taking the Regional Climate Outlook Forum idea, taking the outlooks and have them construct how they're being impacted as part of the data sheet. This will take more work and is outside of the present purview of the method hydrologic services, but we find it to be a useful mechanism for interaction. So the next slide is basically the global framework for climate services and how the outlook interact with the national method hydrologic services and vice versa. Part of this. So out of the global framework, the GFCS is listed, the components are there, but how interaction should take place is not as clear. And so what I've offered in the last few slides is just some examples of that. The next slide is a critical one because we tend to think of communication as the answer to how we do things. But no matter how well designed institutions are, they're only as good as the people inhabiting them. And that's where the number of personnel needed versus those who are trained to conduct vulnerability and risk assessment become very critical. So from that standpoint, who is trained to do the analysis and conduct the deliberative process is critical. So to just wrap up, what is needed in the climate and services challenge is integrating research, development, prototyping, and services. And that's one slide that I can show there. And the case that we have, the next slide, is basically saying, well, when you link monitoring, analog, and prediction, you're coordinating the national and state levels, but you're also identifying and transferring innovations that are occurring globally. So it gets at one of the issues that was in the GAR last year, which is decentralizing the implementation, the impact, and the assessment of those impacts, and having some centralization of the standards and practices that have to occur. So what I'm trying to offer is some of the lessons from drug risk management on how to do this and what are the core activities that method hydrologic services would have to entertain to really develop climate services. So the last slide is just thanking you for letting me do this. Okay, thanks, Jim.
Thank you very much. So we'll follow up on that with the WMO and the GAR and let you know. Many thanks.
Okay.
So now is really how all of this comes together. Yeah.
Well, this final presentation is short. It's about how can we get access to this information, to support risk analysis and mapping. from the various, through the different channels that's made available. This information has been provided by the WMO. Essentially, the current and ancient methodology of distributing weather information is where the data flows from the source instrument into observations itself and then gets processed as messages for distribution around the globe. And this is known as the Global Telecommunication System. It's been running for a couple of decades already, and actually quite successfully if one think of the availability of technology 30, 40, 50 years ago. But there are challenges with the GTS system, and this is, for example, the system is based on a data push distribution model. Data is only pushed in one direction or from the provider itself. It's very internally based to the meteorological community. Only weather services are linked into the system itself, and there's no other user outside there that's linked into the system. And it does not allow easy data availability for researchers and other people. There have to be different mechanisms. You have to get the data directly from the weather services and not via the GTS. And there are a number of countries that's so-called regional telecommunication hubs in this particular system, also in Africa. And this is a broad slide of how this typical, this GTS is working with the NMCs, pushing information to the RTHs, and then from there it's being pushed into a couple of main RTHs, which then will disseminate, make bulletins and disseminate that back to the NMCs itself. And it's quite a mess, as you can see on this particular slide. So enter now the WMO information system, or WIS as it's been called. And this is a new system that will replace the GTS in the next couple of years. The idea is to have an overarching system that will both allow for push and pull of data. And this was, the concept was adopted by the WMO in 2003, and then this project has been initiated. And there are three major components in this project. One is obviously the national centers, or the NCs or NMHSs, where the observations are being done. And then there will be the so-called DCPCs, data collection or product centers, which replace the old RTHs. And then there will be global information system centers where all the data will be basically residing, and that will be distributed around the globe itself. And together with a data communication network connecting the components, this will make up then the WIS system. The WIS DCPs and the GISCs, they will keep metadata catalogs, and I think that's a very important addition to this whole thing now, because the metadata will now pointing to the data sources and from where data will then be available through the internet, and it will be much easier for users now to identify which data they want and where that data resides. And this is now a picture of this, where the national centers is still on the outside of this whole thing, and then the data will be through the DCPCs, particularly the metadata to the GISCs, and from there it will then be easily available through internet and through various kind of mechanisms to the users, as well as obviously the weather services themselves. So there are being 13 GISCs nominated already. Some countries are already active with this concept. It's not only something that's been planned, it's already active. Particularly operationally is Germany, Japan, China, UK and France. And there are a number of others under development, including one in South Africa also. There will be various DCPCs also in Africa, and WMO is monitoring this project then from a central office. The bandwidth recommendations is obviously very important, and there are certain recommendations of minimum standards that should be there to make this data available for all the centers itself. It will be a problem in Africa, as we know, but that is something that we have to work on. Yeah, I think the functionality of this, the sharing of data between various sectors will be made available. Enhanced research due to data accessibility will be promoted through the system. The metadata captured in data catalogs will be an advert for data availability to users. You people out there will have access to this metadata and see where the data is and what kind of data is available. WIS will allow now for a push-pull mechanism, which overrides the current RTH push-only system. And standardization of metadata throughout the NMHSs will also be part of this whole thing. And there's a total redundancy for global data availability because there are a number of JISCs that has got this data available. Distribution of products and services to the Met services. WIS will enable weather service to collect the data from sources that have been hidden in the past. The metadata catalog will be a vital tool. And then the other data sources, for example, EUMETSAT, NCAR, ECMWF, and others will also be on this system. And then from the Met service to the users out there, you people, the various platforms can be used for disseminating of data, of warnings, of services, through internet portals, through mobile devices, media, and other mechanisms also. Important other activities, the Global Framework for Climate Service. I'm not going to talk much about this. This is already being elaborated by both Mariam as well as now Roger also. But it's the whole idea of the Global Framework for Climate Service is to enable better management of the risks of climate variability and change and adaptation to climate change through the development and incorporation of science-based climate information and prediction, and make available new services through this whole process. This is a new activity that's being at this moment being or discussed at the WMO at the Executive Council meeting happening this week in Geneva, and it's a multi-partnership activity with other global partners also beyond the WMO, like UNICEF and so forth also. So in conclusion, WIS will be an enabler for creating awareness around the initiatives of Met services and their capability by acting as an advertising portal for products to the community out there. Centers of excellence like NCAR, as I mentioned, EUMETSAT, ECMWF, and others that were up to now excluded from the GTS will now be part of WIS. And then the Global Framework of Climate Change, Climate Services rather, aims towards the production, availability, delivery, and application of climate service in the four priority sectors, namely agriculture, water, health, and disaster risk reduction. That's going to put climate service into a completely new league once that is up and running. So there are a lot of developments, and to make information more easily accessible to users out there for risk analysis, both from the Met service as well as from the WMO through this new activities. That's all from my side. Thanks, John. Please.
I believe it's not time anymore for questions and answers, but you may be able to connect directly with the different speakers during the afternoon. From the World Bank perspective, we are investing in modernizing national Met and hydro services, and the risk, how to get a Met service and hydro services that can support risk mapping, among others, will be in the future a priority for these projects. And we are starting with the Dutch an initiative under the Water Program Partnership Program to address in the lens of water, for example, for now, the disaster risk reduction needs when this national Met and hydro service are modernized. So we have also an interest in better linking the potential of these services with the projects that are in the pipeline. And thank you again for your participation. Bon appétit. And I wish you a pleasant end of the forum and journey here.